Okay, I wanted to go over a little bit of the homework from last time. Actually, remember it was the pair work. I do have the homework sheet. It's in a folder over on the table across from my computer by the extra copies book where it says bonus work. You're welcome to do that for bonus points. Okay, the first problem only had a greatest common factor. Remember, when you undistribute, I should be able to go back and get my original. So 3a times 1 does give me 3a. 3a times 2a does give me 6a squared. 3a times 3a squared does give me 9a cubed. So that one works. Now, the next few are the pretty easy and simple patterns. This one is a perfect square. A times a gives me a squared. 3a plus 3a is 6a, and 3 times 3 is 9. Works pretty good. The next one is the same thing. S times s is s squared. Negative 4s and negative 4s give me negative 8s. Negative 4 times negative 4 is a positive 16. You didn't even need to use the square on this. 4h times 4h is 16h squared. Negative 20h plus 20h goes away. These are what we call those conjugates, where it's the sum and difference. The middle terms are always going to cancel out. 5 times negative 5 is going to give me negative 25. Perfect. Next one's another perfect square. It's just bigger. And the way you can notice this is if you have those perfect squares at the beginning and the end. 3x times 3x is 9x squared. 21x and 21x gives me 42x. And 7 times 7 is 49. These are matching those special patterns. Same one here. 8x times 8x gives me 64x squared. Negative 8xy and a negative 8xy would give me negative 16xy. Negative y times negative y would give me a positive y squared. You could have used the box on these, but you don't need to. Now these, again, you could have used the box, but when there's not a coefficient in front of x squared, you don't really need to, because the only options to fill up your first box are x and x. So x times x is always going to give you x squared. 3 times 4 gives me 12, but adds to give me 7. Works great. Here again, x times x gives me x squared. 4 times negative 3 gives me negative 12, and add to be positive x. Number 9. X times x gives me x squared. Negative 5 times 2 gives me negative 10. But if I add them, I get negative 3. X times x gives me x squared. 5 times negative 2 gives me negative 10, but they add to give me a positive 3. Notice the difference between these two problems. The negative 10 is the same, so I know these have to have opposite signs. But here we get a positive 3, and here we get a negative 3. So that's how I know which one's positive and which one's negative. Now, 11 and 12, I would probably use the box. It's a lot easier. So if I had 2x squared plus 5x minus 3. Now, if we're using the box, I know that the first term goes here. Last term goes here. These two add up to be the middle term, but they're the same product as the other diagonal. If I multiply these two together, which I could do here, it's negative 6x squared. So I need something that adds to be 5x, but multiplies to be negative 6x squared. The only way I can do that is with a positive 6x and a negative 1x. Now just see what happened. To get 2x squared and 6x, this would have to be a 2x. 2x times what gives me 2x squared? X. 2x times what gives me 6x? X times what gives me negative x? And then does negative 1 times 3 give me negative 3? It does. So it works. My factors are 2x minus 1 and x plus 3. Same deal on the next one. But the following ones are following that special pattern. We have a difference of cubes. This is the pattern we looked at last time of difference of cubes. You'll also see it when you get your factoring flow chart. It'll be on there, and it's a great way to reference it whenever you're doing any of your homework. If I have something cubed minus something else cubed, it's always going to break down into this exact pattern. There's no guessing. Another thing to note is that this quadratic part is prime. In other words, it will never factor anymore. You're done. So it's a handy little thing. So let's see on this next one. I had x cubed minus 8. Well, 8 is really just 2 cubed. So instead of having y cubed, this time I have 2 cubed. So everywhere there's a y, I'm going to put a 2. So it'd be x minus 2, and then x squared plus, it said it was x times y, so that's 2x, plus y squared, that's a 2 this time, so that's just 4. On this one, we still have the y cubed, but this time we have 8x cubed. Well, that's really like having 2x quantity cubed. It's like having 2 cubed and x cubed. So in the pattern, every time we had seen an x by itself, on this pattern up here, this time we're going to replace that with a 2x. So when I'm taking a regular x and squaring it, this time it's going to be 2x squared, which is 4x squared. X times y is now going to be 2xy. On the last one, 27 is really 3 cubed, and that's x cubed. So this is really 3x cubed minus 4y cubed. It still matches the pattern. All you're having to do is plug into a formula.